this walkthrough is going to begin with chapter 3 with probability. This will be question 12 and question 14 to start with. So 3.1 basic concepts. The first question was identify the sample space of the probability experiment and determine the number of outcomes in the sample space. So the actual sample space would be the actual elements. So the outcomes here would be so if I was rolling one die, so the sample space would actually just be the numbers on the die. So 1, 2, 3, 4, 5, and 6. So that's going to be your sample space, your outcomes, if you will. And the number of outcomes, 1, 2, 3, 4, 5, 6 outcomes. So number of outcomes is just how many different samples we have in there. So just 6 different samples or outcomes. So that's all we're looking for there on that. So 3.2, conditional probability and the multiplication rule. So the accompanying table shows the number of males and female students in a particular country who received bachelor's degree in business in a recent year. Complete parts A through A and B below. So find the probability that a randomly selected student is male, given that the student received a business degree. So we're talking about given a business degree. So business degree is a known fact. So we're basically looking at this column here. So find the probability. Remember, it's going to be the number of successes divided by the total number of outcomes, if you will. So 180, since we're talking male, 184,057 would be the successes out of this 355,624. That would be the probability. So I'm not really sure how they want the answer in my lab. So one way is if I type in 184,057, if I divide that by 355,624, hit enter. One way to be is it could be a decimal rounded to maybe the thousandths place or something. So if I was rounding to 3 decimal places, that would be 0.518, 3 decimal places. But I really can't remember what decimal place they want that to. So a lot of times they'll leave the probability as a decimal. If I want a fraction, if I hit the math button, number 1, turn it to a fraction, that answer just basically stays the same. So it's probably better off being a decimal for that. So the other probability was find the probability that randomly selected student received a business degree, given that she is female. So now we're talking about it's female. So now we're looking at it from this direction. It's known female. Of all the females, how many actually received a business degree? That would be 171,567 divided by 1,111,781. So if we put that into the calculator, 171,567, if I divide that by 1,111,781, if I hit enter, that'll give me then this 15.154. So, so it's interesting, 15% of the females surveyed, only 15% of those actually earned a business degree. Most of them pursued a non-business degree there. So that's how we would kind of do that. So pay attention to the given. The given tells us what column we're going to be going in. So given that the student received a business degree, that told us that we're focused on the business degree column. Given that the student is female, that's going to tell us to use the female row there, if you will. So the next question is question 15, permutations and combinations. Evaluate the expression and express the result using the format for writing numbers instead of scientific notation. So this basically just wants you to write it as a normal number. So 35 choose 2, this is a combination, and we're just going to the calculator do this. So remember, if I use the math button, number across here is the probability, and notice that number 3 is going to be that. But to do this, though, we actually have to choose the n first. So if I quit that, so if I choose the 35 and then hit the math button, go to probability, go down to number 3, notice how it's now waiting for the 2, hit enter. That'll give me then the 595 different combinations there. So again, that can be found under the math button. And that's going to be also noting that we look for the probability inside there. So math, slide over to probability is where you get that menu at to do the combination. So let's see what we'll get into next here. So chapter 4, discrete probability distributions. So this question here is use the probability distribution to complete parts A through D. So this is our probability distribution. So the probability distribution of a number of televisions per household in a small town. So the number of households with 0 TVs was 0.05. So that's like 5% of the houses had no television. So one television, so 13% of the households had one television. 2 televisions was 27%, if you will. 3 televisions was 55%. And I think in our house, we have 3. So that makes sense that most people these days probably have 2 or 3, maybe even more TVs these days. But now a lot of y'all are starting to use your computers. So you may be diminishing on the number of TVs because you're starting to use different types of tools besides the television. So part A says, find the probability of randomly selecting a household that has 1 or 2 televisions. So 1 or 2 kind of means to combine these together. So the 1 was the 0.13 plus the 2, which is the 0.27. So if we add those together, we end up with like 0.40, it looks like. If I want to double check my math here, 0.13 plus 0.27 does give me 0.40 or just simply 0.4. So that's what that would be A. Just put those together. Question B says, find the probability of randomly selecting a household that has 2 or more televisions. So 2 or more means the 2 and the 3, since that's all we have here. So that means we're going to be putting the 0.27 plus the 0.55, putting those together. That looks like 0.82. We'll double check it here. 0.27 plus 0.55. That does give me 0.82. So 82% have 2 or more televisions. So find the probability of randomly selecting a household that has between 1 and 3 televisions inclusive. Inclusive means count the endpoints as well. So this means 1, 2, and 3. So what we're adding together is the 0.13 plus the 0.27 plus the 0.55. So if we add those together, now we've already added the 0.27 and the 0.55 together. So really all I got to do is add the 0.13. That gives me then 0.95. So 95% of the households had between 1 and 3 televisions inclusive. And part D says, find the probability of randomly selecting a household that has at most 2 televisions. So at most means 2 or less. So this means 0, which is the 0.05, plus the 0.13, plus then the 2, which is the 0.27. So you can add all those together. So it'd be like 0.05 plus 0.13 plus 0.27. That gives me then 0.45. Now you also could do the complement. You could have also said 1 minus the 0.55. That would also be another way to do it because we're excluding the 3. So remember, probability has to add up to 1. So if I would go 1 minus 0.55, that also would have gave me the 0.45. So I could also use the complement there in that situation. Okay. So chapter 5, we're doing normal probability distribution. So this is we're getting into the curves. So use the normal distribution to the right to answer the questions. The percent of scores that are less than 19 is what percent? So again, we could use tables, but I'm also going to just use technology here. So in technology, notice how we have to do the distribution button. That's above the vars button. So if I hit second, that'll do distribution. The one we want is the normal cumulative. So we want the normal cumulative distribution function is one we want to choose there. So number 2. So less than 19%, we want to find the area of the curve that's to the left. So remember, the lower bound is going to be a really small number. So we usually use a small, like negative 10,000 here or something. That's like, what, 4 zeros. The upper bound is actually going to be the 19. Our mean is going to be the 20.5. And our standard deviation is going to be 5.2. So we put that data into the calculator, and it'll actually do the area of the curve for us, the probability. So we end up with this 0.3864, blah, blah, blah. So notice how it says round to 2 decimal places. So notice how it also has percent. So we have to actually move the decimal 2 places to the right. So we have to decide, so is this going to be 38.64 or 65? So the decimal is going to be here, 38.6465. That 9 is going to dictate, we're going to say 38.65%. So from there, our next question says, again, I've left this off, but out of 1,500 scores, about how many of those scores would be expected to be greater than 21? So they actually want to determine the number of scores. So first we need to find out what percent of the scores are greater than 21. So to do that, we hit the same thing. We hit the second distribution, number 2. Greater than 21, though, notice how 21 becomes the lower bound. And our upper bound is going to be some really big number, so we'll just use 10,000. Again, the mean is 20.5. The standard deviation doesn't change. We put that in. So this will give us this 46 point. So we're going to say 46 point. Is that going to be like 1.6 or 1.7? Looks like 1.7%. So basically, to do this without a calculator, to do it with the calculator, we got to change it back to a decimal, 0.4617. And if we multiply that by 1,500, that'll tell us actually how many scores are greater than 21. So 0.4617. If we multiply that by 1,500, that'll tell us how many scores were actually greater than 21. So, and this says round to the nearest whole number. So 692.5 would round to 693. So this would be 693 scores would be expected to be greater than 21. Okay. So the next question says, find the indicated z-score in the graph shown to the right. So let's see what we can figure out here. So next question I want to do is question 19. Find the indicated z-score shown in the graph to the right. So notice how we have the area of the curve, notice how it's going to the right. So to find the z-score, I like to use the calculator again, not the tables. So if I had second distribution, remember to do the z-scores, we have to use the inverse normal. So that's number 3. So we use the inverse norm. So if you choose number 3, the area of the curve is going to be, if we use what they give us, is going to be 0.0618. Notice when you do z-scores, the mean is the 0, the standard deviation is the 1. And this would be right-tailed since it's skewed to the right. And if I hit paste there, that'll give me, if I round that two decimal places, it would be 1.54. So that 3 would be rounded up because of the 9 after it. Now, we also could do, if I do the area to the left, I could go 1 minus 0.0618 if I do left skewed. So if I do 1 minus 0.0618, that'll give me this 0.9382. So if I get second distribution, if I choose number 3 again, if I use the 0.89382, I can't read my own writing there. I think that's 0.989382. This would now be left skewed, area to the left. And that's how I get the same answer of this 1.54. So there's a couple ways to do that. Okay. So question 20, it's like 5.4 sampling distributions and the central limit theorem. So first part is the height of women's ages 20 to 29 is normally distributed with the mean of 64.7 inches. Assume the standard deviation is 2.8 inches. Are you more likely to randomly select one woman with a height less than 65.8 inches, or are you more likely to select a sample of 30 women with the mean height less than 65.8 inches and explain? Okay, so we have a two-part question here. So part 1 says, what's the probability of selecting one woman with a height less than 65.8 inches? So this is just going to be your normal distribution with the given information here. So we're going to hit the second distribution. We're going to choose number 2. Notice how it says with a height less than 65.8 inches. So our lower bound is going to be a really small number. I usually use negative 10,000 there. The upper bound is going to be the 65.8 inches because we have to be less than that. So since we're using the actual mean for the population, the population was, the mean was 64.7. And the standard deviation was this 2.8. So we get this number here. So if we round this to 4 decimal places, we would have 0.6528. So 0.6527 up 0.6528 would be the probability. So around 65% of selecting a woman with a height less than 65.8 inches. So part B, what we want to do is we want to determine the probability in a sample of 30 women. So part B, I don't think I wrote down part B. Part B would be here. So because we have to compare the two. So we're actually doing a sample this time. So to do the sample, we're going to be using the central limit theorem. So central limit allows us to find a z-score for the sample. So to find the z-score, we use this x bar minus mu divided by sigma divided by the square root of n. So remember, x bar is the sample mean, which they said was 65.8. Did I use the right numbers there? 67, or did I use? Yeah. So we have the sample mean again. It's going to be 65.8 inches. Minus the population mean, which was the 67. Better double check, make sure I used the right population a minute ago. So second distribution to, I used the wrong one there. I should have been using the 64.7. No, 65 would be there as well. Okay. Okay. So that's where the 64.7 went in there. Okay. All right. Making sure we use that right formula there. So to find the sample mean, we have the 65.8 minus the 64.7. And then we're going to divide this by the standard deviation, which is this 2.8. And then the sample population was the 30. So we divide this by the square root of 30. So to do this z-score, I'm going to go ahead and do the top 65.8. Let's go ahead and clear this off here. So 65.8 minus 64.7. This gives us did it wrong. 65.8 minus 64.7. This gives us this 1.1. So I'm going to use the fraction button, alpha F1. So on the top, I'm going to just put a 1.1 in. On the bottom, I have another fraction, so I'm going to get alpha F1 there. So I have the 2.8 was my standard deviation, and on the bottom, that's the square root of 30. So this will give us a z-score. So this is 2.8 divided by the square root of 30. So our z-score was 2.15. So what we have then, the area of the curve is going to be less than this z-score of 2.15. So basically what we're doing is, if we're using the z-score of 2.15, remember we have 0 is here. When you use z-scores, the mean turns into 0. So 2.15 is going to be out here somewhere. So it's that most of the area is going to be covered there, because that's going to be everything to the left of that. So it should be close to 90-something%. So to do the area of the curve, we're going to again do the same thing, the distribution. We are still doing the left bound, but upper bound this time is going to be the z-score of this 2.15. And here we do keep the 0 and the 1 in place since we're using z-scores. We hit enter, and that gives us then this 0.9. So our probability then becomes then this 0.9842. So which is more likely, the 65.28 or the 0.9842? So it looks like it's going to be more likely that you're going to see a woman, if I do the sample population of 30, most of the time I'm going to get a woman that's going to be less than 65.8 inches in my sample. So we kind of come up with that in that sampling. All righty. I'll pause there. There's a lot in chapter 5, it looks like. So again, notice how the first part, we still use the key thing was we were using the distribution. We were doing the normal distribution. So that was the norm cumulative distribution function. Remember that goes like, just pay attention to which direction we're going. Most of the time I like to go from the left because most of them it seems like they're less than. But every once in a while you'll have a curve thrown into us. So the first one, we had to use the population mean and the population standard deviation. But in the second one, to find the central limit theorem for the sample, we actually had to do the z-score to find the second part where the sample size was 30. So we then used the 2.15, used again the same function to get our probability for that as well. All righty.